Okay, good morning. And last week we have a testing, and the testing paper we will discuss it on next week, and give to you. Do you understand your score? And then today, the first part is I will introduce about our unit. Will introduce about the ANN, the artificial neural network, and the neural network. We also have a subject, subject lesson. I think some of you have joined. So in this part, we will focus on some traditional. You need to understand. And then, but now artificial intelligence, that for advanced application, many of them use the related neural network. So we have two reports. One is maybe some of students today can share your conference paper last time. And the second report or final report, that is based on, I hope you can read. You can read about this topic because this topic is the trend of currently. Now for you do the neural network, that the AI related topic, many professors, many scholars, and researchers, they focus on this part, like the expert system in AI. Expert system with traditional system, the difference is the expert system can do the explanation. So now many neural networks, different kind of neural networks, CNN, RNN, and some reinforcement learning, and so on. But more scholars hope to understand this clear, explainable AI, that interpreted and explaining and visualization deep learning. That is the very hot topic. If you do the PhD study, you hope study in the AI, that this topic is interesting, and many hard research on this field. So in this field, I already upload this book on our website, Fun Class. You can download. And this book, he has many chapters. It has many chapters. Include the power of the transparency, AI transparency, and this from here I suggest some of unit. Totally I suggest 6 units that I already post on our final owner report. That you can select one of them. Maybe not repeat. Student not repeat with other students. Not select the same paper. This unit sometimes many books that based on special on Springer or something. They have this topic. Based on this topic, and many different people, different researchers, he post a paper, post his research on this topic. So combined to a book. So this kind of the book we say the chapter of book. So sometimes when you become a professor, you have published paper, you will have an invention that led you to write chapter of the book, chapter of book. So like this, I already select 6 paper, 6 unit, 6 chapter, or maybe 6 chapter, 6 chapter. So you select one, but not repeat. So maybe Christine can help that. For example, if Benny already select the number of the index is this one, already select the index 4, then other students don't select. So if you select, you post on the discussing area of the class. Maybe Christine will help you generate a discussing area about the final owner presentation, paper selection, chapter selection. Okay. The chapter I already post. You can. So now that you have more time to prepare. If you can finish early, it's better. You can select a paper and to do the reading and understand the trend of the AI technology. So this is the hot topic. Because this book is published last year, 2019. Okay, this is about our final. And another thing is that on July 5 is next week. Because I have a meeting outside in the morning. So that course, based on you, I have looked that have some students have class on the Friday afternoon. Today afternoon have class. No? So maybe we just change the time from morning to afternoon. Have some question? No? So just only July 5. And another time is school hop. That because in Taiwan schedule, that July maybe on July 24, I think, around here, have a 4-day continuous holiday. But he said our class is on 5 days. 5 days need to have not come back, but you need to in advance have for something. So at that time, maybe I just record a video. Video you can share. You can just learn by yourself during that vacation. Okay. So this is the textbook. Textbook from the Springer for your final report. Is planned for the AI topic. Okay, and then we go back here. Go back here, learning about the artificial neural network. Artificial neural network. Neural network, like the machine learning, we have two types. One type we said is the supervised learning. Another type is unsupervised learning. But on machine learning, the supervised learning and unsupervised learning also have similar supervised learning. Similar supervised learning also have a different type. Previous, I have a student. He already finished his PhD degree. That is do the research about the semi-supervised learning, and he published many high-quality papers that do this topic. But supervised learning means that the training pattern, you need to know the output. You need to deliver output. Like many image processing currently, that they need to mark with what kind of the image. For example, this image is a dog. This object is a dog. This object is a car. This object is a human. You mark different labels, so that can let the computer to learn. So now some research say, and some business model, he said there are a group of people. His job is just only to do the labor on computer, to generate the training pattern, Because based on the supervised learning, we usually need to labor by human, because computers here have not enough intelligence to automate it to labor object, but still have research to do the labor object. But that usually based on they already have some data set that with labor. So in this topic, the first part, we just introduce the surprise learning, and another topic is unsupervised learning on ANN, artificial intelligence. Now, as we know, in fact, there are many different kind of the neural network, like the whole field, like the brain. In fact, in 1980, many different kind of neural network are proposed during that period of time. That is a hard time for neural network. So, like a CNN, RNN, that seems a new one. But in fact, that neural network also the old one. That also at that period of time, and just only make some modify. But at that time, the computation ability is not good enough. So at that time, we understand this idea, but our neural network usually less than 5 level at that time. Usually less than 5 level. So, but now the computing ability due to the like company Nvidia
he has some graphic card that can do the powerful computing. That the data can be more and more, or even 100 data or above it. So the first part, we introduce the base of the neural network. The base of neural network is that I think that is the perpetual is the simple one, and then backpropagation neural network, and then Hopfield is traditional. That from Hopfield idea, we generate many different kind of the neural network. That for neural network to do the short-term memory, and so on. So how the brain work? I think we will not introduce about this because this is very basic in the neural network. I think if you join neural network, so some student, all of the professor student, all of PhD student have joined the neural network course. Just Benny have not joined. Okay. Benny may be arrived later, but I have discussing with that professor. He said the course already had maybe 5 weeks.
Yes.
5 weeks. Now she hope you join next time. Okay. So a neural network can be defined a model of reasoning on human brain. Previous some course I test students to watch the video about how our brain operation. Because brain is an important part. It control our mind, control our body. For example, at that time, the president of North Korea that have some people said he had some problem. That also the brain problem. Now many old people, his brain may be the black, the breed are black, that his body cannot control. That is based on this one, the brain. So human brain that incorporate nearly 10 billion neurons and 60 tera. Tera is the order of the 30 T. So C has a center between them. That is like a wave, neural network, like a wave. Then our brain for operation. So a neuron can body neuron is consist of a cell body, a soma, a number of the fiber called dendrites, and a single long fiber called axon. That is like this. So this is like our model, our neural network model. And this sometimes may be not connection, but if he has a power, has some action, that this connection can connect. So have many training. If you still if you have children, your children are small, he said that have science proof that your children not to walk quickly, just only maybe crawl on the ground a period of time. That will be good for brain. But why good for brain? Because the brain will set up more connection. More connection means that he can have more idea, and he can have more method to solve difficult problem. For example, if this is the location our school here, this is the location of the Taichung station, Taichung train station. If you only have one path, you just only know from here to here. If you have more trigger previous, you have learning, then you understand you can by this way go to this destination. You also understand another way to go to this destination. This is why we need to do more train for some system. But computer sometimes after train he only select one path. Our brain also after you training a period of time, he usually select this path. But sometimes maybe your body have a problem. This path is broken, and then your body still, your brain still need to control your hand. Then he need to bypass some other neuron to control. That is the our brain operation. Brain operation previous is a black box. No people understand how our brain operation, but currently is different. Many scientists that he have research biology our brain. He sometimes he can control our brain. So in Chicago University, his research that they have designed a chip that to put into the brain to do prediction for testing your mind, your neural how to operation, you how to thinking. That's also interesting, but also dangerous because AI research is related to the human mind. That is a dangerous research. We have introduced AI is evil or good. Okay. So information is stored and passed in a neural network simultaneously through the whole network. So the architecture of the typical artificial neural network is like this. I think this type we say the perplexon. Perplexon means that the sensor to the sensor. Sensor usually is sense input and then output. But during the output, he have different layer. Not just only one way. One way we said is a perplexon. But even one way, at that time, he said the research said he can solve many problems, especially for the linear problem. Perplexon, most of the problem he can solve at that time. But some people or some research, he have give the counterexample that the perpetron can solve some problem like the logical SO get that perpetron cannot solve it. So we have a new neural network like a back propagation to solve it. Okay. So the body neural network and our neural network, the mapping, that the Solomon is a neuron, that is that circle. That energy is the input, S is the output, synapse is the weight. That just only mapping our brain to the neural network. So the neural network is a simple computing element. So input signal, weight, neuron, and then have output. Between the neuron and output of Y, we have a threshold to control at what time the Y can have an output. So usually we define the mathematical function. This is a sign function. The Si is the input, and Wi is the weight, and I is the number of the neuron, number of the input neuron. So this mathematics is simple. Not just only do the summation. Summation is sum the value. And then after this, he get the value of x. From the s, we define the output with a threshold. We name theta. Theta. If the s greater than theta, greater or equal than theta, we let the output is 1. Less than the theta, we let the output is -1. -1. So this is construct the base of the neural network architecture. So different membership function, different activation function, not membership function. In neural network, we say activation function. Membership function usually used on fuzzy system. And then this is a step. Step is 0 from 1. This is a sign function. Sign is -1 plus 1. That is a symbol. And this is, we say the symbol function. Symbol function. Symbol function is an important function. Important function. And many machine learning algorithms use the symbol function. For example, the logic regression that use the symbol function. Symbol function idea is like a little like the fuzzy. Now the node here, you may say it more belong to this area. This area. And linear function. Linear function. That is some the popular general function. But now the deep learning, we have one more popular function. We say that function. What kind of this function? We say this function is what kind? What the name of this function? Value. This function. You can compare with this function. The difference is in this area, you don't need to computation. because maybe that is 0. So you just only computation this area. But this area, why he use this line? Because this is a linear function. Linear function benefit is computing time is quickly. Because deep learning, the data is so much, or maybe 100 data. If every node you use this kind of function to computation, then the computation time will waste a lot. So use this kind of function is hope to more quickly to do the computation, and also do some field, Okay, and here we said that can a single neuron run a task? So this is he said have a hard limit. We do the single layer that with 2 input capacitor. That the neural network model is like this. Input multiplies weight, and S2 multiplies weight, and then we sum of them, combine, and then have a threshold here, check whether threshold or not, to decide output or not output. So this is a more famous neural network that the Prof's idea. So every neural network, I think, introduce about neural network, machine learning of the neural network. The basic topic is capacitor. Introduce about the capacitor operation. So the capacitor look similar, but application is can do many applications. So the arm of capacitor is to classify input S1, S2 to Sn into one of 2 classes. We say that may be A1 or A2. In the case of an elementary capacitor, the n-dimensional space is divided by a high plane into 2 regions. The high plane defines the linearly separate the function. So we can find if Si here, if n is 2, this problem is 2-dimensional problem. Because we can say S1, we can say we can draw it on the plane. If n is 2, and then we can say here is S1, here is S2. So became 2-dimensional. And then we have a threshold you can define. And here, in fact, if n is 2, this mathematics became so this function can have 2 variables, right? So if n is 3, this function will become became like this, and so on. So the n means the dimension. Dimension. N is 2. Maybe you can draw a line. Draw a line. Draw a line. Draw a line like here. We say your node is below the line or up the line, so we can separate the question to two classes, A1 and A2. If in 3 dimensions, we S1, S2, S3, for example. And then he also hope to separate to A1 and A2, different class. That is a plan. That is maybe like a plan here. That is plan before or plan another side. So for n dimension perpetual problem, in fact, in mathematics also the complexity, even the simple one. So like this, we can find that if n is 2 or n is 3, and then when we draw, that became 2 dimension or 3 dimension. 4 dimension we cannot draw, because do you ever find someone can draw the figure of the 4 dimension? Maybe that is interesting. You can draw it, That maybe you can get the Nobel that people easy to see multi-dimension. That is interesting. How does the perpetuum learn its classification task? This is done by making small adjustment in the weight to reduce the difference between the actual and desired output of perpetuum. These initial weights are randomly assigned and usually in the range of minus 0.5 to 0.5. That is assigned randomly for the weight. Then upload to obtain the output consist with the training example.
So this is more like a gradient descent, right?
Like
Gradient descent?
weight descent.
Yes. Because we take a weight initially and then we adjust.
Neural network, great descent just only hope to find the minimal value. But neural network here, he is do the error reduction. But how to reduce your error? Error we hope minimum, right? So the great descent will apply to the neural network to find the minimal error. Okay? Great descent will apply to neural network to find the optimal solution quickly. Okay? But it's optimal solution. The error is 0. Error is 0. So you have maybe you already have do some training network. Our training curve usually from here to here. That is hope to find the minimum. And then great descent is here. How to decrease? How to decrease your weight? Great descent also. In fact, we just only introduce about the very basic there are some revised type of the grade descent model. Because grade descent sometimes step, how to control the step also a problem. Okay. So have a EP. EP is YD minus YP. YD is deserved, your deserved output. YP may be YP is actual output. So we hope the gap is smallest. And then the purposeful learning measure, that is based on the P is the phase. P is the phase. Phase means all the training data go through the whole network one time. We say a P value. So the next time trend, the weight will be updated. The update method is based on the previous your weight and add a change rate. Change rate, we sometimes say the learning rate, hour, and SI multiplies EP, that to do the learning. So perpetual training algorithm that became initialized, you set the weight value, and the next one, you input pattern, and then to calculate the summation of the neural output here by a step function to check the neuron is active or not active. If active, he can pass to next. And then after all training phase, one time you will get a error. And then you do the update of the weight. WI at delta WI. Delta WI means that the learning rate multiplies SI multiplies EP. Maybe you have question, not why need to multiply this one? Why we don't just only power multiplies EP? Can we do this? You also can try, because this is just the perpetual model. That means their method is this one. So when you do research, no method is just only one can use this type. Maybe sometime you hear you don't use SI, you use SI minus 1, right? Or that is sometime research, especially on the research of the security. They like to change the parameter a little and then publish a new paper. So we introduced this rule. That is some research or some professor that provide a professional method. His method, calculation method is like this, right? Okay. So then iteration. So we give this example. In neural network course, do you have this example? In your course, have this example or not?
Yes.
Yes, have example. Okay. This is a very popular example. That is for an AND gate. AND gate. Now we can update the weight by person by person. So you know how to calculate this. Okay. Because from here you can understand how the neural network operation. So if you have the trend, Benny, do you know how the value to find this value?
No, I got this desired output because it's an AND function, 0, 0, 1, but I don't know the initial weights and the actual output.
Initial. So maybe some student
Yeah, I'll check it.
can student help me to explain?
Yeah.
I think you can review. That good for you. Okay. Can you introduce about this?
Okay. Yeah.
So for suppose equation is weight x2 x1 w1 plus x2 w2 equal to 3. So we can use theta like that, here minus theta. Okay. Then we put value x1 and x2 value here.
Okay.
So 0 and weight 1 value, which is 0.3.
Yeah.
So we will put into 0.3.
Okay.
After that, x2 value is also 0. 0 into and w weight 2 value is minus 0.1. And
Theta is below. Below. Okay.
So theta is 0.2. So now we will solve this equation for 0. We put 0 x1, x2 value is 0, 0. For 0, 0 value. So the equation, the answer will be, because both are values are 0. So our answer will be minus 0.2. Okay. So this is for 1. But we have one equation where you check the value is the.
You can use the weight.
Where net. So if this value is greater than 1, lesser than 1,
Lesser than 0.
lesser than 0. So this means the value is y equal to 0. And if the greater than 0, that's the y is equal to 1.
Okay.
So then we put the next equation, which is t minus y equal to 0. This equation will be 4. If this equation is right, suppose t is our
Actual desired
0
output. Okay.
and y, which is I found here. So this is 0
Okay.
equal to 0.
Oh.
So this means the equation is fulfilled.
Okay, so this where will you apply? Error?
What?
That's a error.
T value from this table.
No, you find error.
Yes, yeah.
Okay.
So for this equation we solve, we get the equation is our verified. So now we will go for the second one.
Okay. So now how do you find the W1 and W2? Like
W, this
final
one?
weights, no, the last one, final weights.
Final weights. When you calculate it, if the equation is not fulfilled, suppose you don't give the equation like this, not equal to 0, then you will update your weights.
Okay.
Then you update your weight equation like W11 equal to
So there's an equation
for inputs x1 x2, so into
Oh, okay.
so you will get the next, and after that you will use this one. So
So there is an equation to get the W1 and W2.
yes, yes. After that you when the equation is not fulfilled this condition, then you update your weights.
Okay.
After that you can get this
Values.
this one. You can check the equation weight are changing.
So only the minus one. Then the error is minus one. The weight has changed.
Yes.
Okay.
So it depends your equation is when your equation is not verified. Suppose your equation sometimes verify these three equation, these three inputs or these three input, but not verify for this. So you can update again and verify for every one.
Okay.
You can try many times if not your equation is verified.
So until we get it, the error is nullified.
Yes, yes.
So keep trying.
When your weights verify for all the input, then your problem is solved.
Okay. Thank you
Okay.
all for understanding.
Okay. So you can understand, because the weight update is follow the perpetual formula. Every iteration, that means that the first pattern, then you use initialize, and this one, the important part is this one. This one is based on our multiplex input, input node, and multiplex EP. EP is the YD minus YP, that the error, that is the error. Okay. So this is an operation. We set all the pattern because the AND gate, all the pattern is for two input. All the combination, possible combination input, and then we run one time. We set the actual, and then the second pattern output. After this, we calculate the error. We hope all the input of the error is 0 is better. So after training, and then all the error is 0. So the weight, finally, the weight we find, and then the weight value will be set up on the neural network, became the model. That means this model can solve any problem. Okay? We take a break. Okay. Okay. This is the end operation. But sometimes for the problem of the we said the S4 is not doing good because from here we can find now from the end operation only both of the input S1 and S2 is 1 have an output. On other condition the output is 0. Or other condition. This is use the graphic to show. And then or so we can easy to find a line to separate it. Capacitor can do it.
And this one, all operation, only one value is 1. Output will be 1. So this 3 node is 1. Only 0, 0 input, output is 0. So we also can find a line to separate it. But for the SO, is a problem because we only one input is 1, other is 0, can have output. So their output 1 is this 2 node. Because this 2 node we cannot find a line, find a straight line to separate it in any way.
We need 2 lines.
Yeah, we need 2 lines. But perfect storm usually only have 1 line. His model. So you need to have 2 lines to separate. But traditional perfect storm cannot solve it. So this is a weakness of the perfect storm. So that means only one layer perfect storm cannot solve this problem. So we need to have multi-layer. This idea is why we use the deep learning, because many nodes are difficult to separate. We need to more layer to do the processing. Each layer sometimes doing different method. So we let you to do the owner report of the final. That is expandable AI. That is to try to find the neural network inside the layer. Which layer do something, which layer do something. Because you only have the idea to understand, you can control the neural network. Our previous research, that may be 10 years ago, few of people, rare people, talk about how to explain the neural network operation. We just show that it's black box. Neural network is black box. But now, many research now hope to open the black box. In 2017, our PhD student also published a paper to show that on different layers, the neural network output distribution. So at that time, we find that some layer is do the clustering. You will find in some phase they do the clustering, and different layer they do different things. So that's interesting. Okay, so we need to multi-layer to solve this one. So multi-layer professional. So with 2 hidden layers here, 2 hidden layers. We hope use multi-layer to set the SO problem. So the layer, not input, not output. We set in the middle. Sometimes we set the hidden. Because previous the neural network we cannot understand their operation. So that is black box. So we set inside is hidden. So only input, hidden, output. A hidden can be multi-layer, even 3 or 4 layers. So he said that for business, for community, that and incorporate 3 or sometimes 4 layers, include two hidden layers. Each layer can contain from 10 to 1,000 neurons. But now the control neuron just by program is easy. Experiments neural network may have 5 even 6 layers, include 3 or 4 hidden layers. Utilize millions of the neurons. So at that time, at previous, this neuron operation time is very long. Sometimes we run a neural network, you need to wait how many days, wait many days. So for solve this problem, we like the SO, we can use the backpropagation neural network also. And this is most important supervisor neural network of backpropagation. So in a backpropagation neural network, the learning algorithm has 2 phases. One phase is training, training input pattern, like a potato, that propagate the input pattern from layer to layer until the output pattern is generated by the output layer. If pattern is different from the desired output, an error will calculation, and then propagation will backward through the network. So the backpropagation is 2 ways. That the propagate and back and back, and we keep to do this until the error is less than a threshold, or maybe you can define the number of the electron. Right? So, for example, you define 100, then you run 100 times. All the data be run 100 times. The program permeate. The program will permeate. So this is based on a 3-layer. 3-layer backpropagation neural network. We can forward and then the roller is backward. The backpropagation training algorithm set all the weight and threshold level of the network to random numbers uniformly. That the weight usually is a random value. Here he said the weight is this range by random. And Fi he said is the number of input, number of the input. But this is not the fees you can generate by yourself. And then also as the same with the potato, do this formula. This formula is the same with the potato. And then calculate the actual output, yk, where n is the number of the input neuron, k in the output layer, And then it's more complicated is to do the weight training, And then this is like
previous we said that update the weight in the back propagation neural network, propagating back the error associated with the output neuron. And then we calculate the error rate for the neuron in the output. And then we can find that here we calculate also the data of the weight, our YP. YP here is the output, is the output node, and theta K, okay. Okay, for the weight training, we need to careful is this item, theta, delta, K, this value is from the output, YK multiplies E minus YKP, and then multiplies EKP. But maybe you also have a question. Why have this formula? That's just the back propagation method. It defines parameter need to set it like this. But that also legal one. That because this is because now the training side is from output to input. Our training side, we hope the error is minimum. So this formula just based on the back propagation method, and then we can update the weight. The weight is from power multiplies yj, and then multiplies delta kp. And then you look this mathematics, you need to careful is the under parameter. This j to k, this the connection weight is from node j to node k. K is which node? K is output. K is output. J is from output to the destination. That is J. So this node, the value is the not the output node. That is destination node. Now, for example, like this. Like this. This is YK. This YJ. So J is here. So when you update the weight, you are from this node to this node, update this value. And in advance, and then you from this node to this node to update this value, or from this node to this node to update the weight. Be careful. So we forward to calculation del y and compare with our desired output. So get an error, and use this error and this node value as the input and to calculate the weight. Okay. So when you look the formula, be careful for the under-index. The meaning of the under-index. You cannot just only look the method. You understand the method, you need to understand the index. Here is WJK, like this, like this, J to K, J to K the way, and then update this way, this way. And the weight training continue. Continue means because we just only one step, and then we calculate the error grade from the linear in the hidden layer. In the hidden layer. Now we also continue to calculate. Because previously we calculate is from K to J. Now it's from J to I. That depends on how many layers. So the back propagation. And the measure is the same. And then by you here need to be careful. Is here the delta J the value. That is a summation from K is 1 to L. That means this node connect to many output nodes. All the output nodes, previously you calculate the theta K need to calculation and summation to this node, right? This is be careful to that. And then iteration to do this. So I think I also explain again this node. So means when you calculate from this node to this node, you need to find this node the neural value. This neural value for back propagation, for update the weight, is come from this node, and this node. Okay. You need to this node multiply this weight, and then summation to get this, and then update. Okay. Okay, and finally, after training, he said that this one can solve the inclusive OR. 3-layer neural network also can solve the SO problem, but this is like the perpetron, but he defined many theta 3 and theta 4 different effect value input the system. And then that is training. After the training, get the threshold. Okay, then the detailed operation of back propagation, how the calculation we will drop. This is the SO. SO use not network. Sometimes we training neural network. The error may be not 0, but less than a threshold. That is okay. Is okay. You are acceptable. And then sum of square error. Sum of square error. That means you square it, and add it, and root square, and find this value. another topic is the how to estimate the learning in multi-layer neural network. The learning maybe we can use some function. He said a multi-layer neural network learns much faster when the signal activation function is referenced by a hypercognate. This is a function, hypercognate. That where AB is constant, that suitable value for AB, that is that the transfer function may be like this, and then that we also calculate the training by include a moment term. Moment term, that is the value, the constant value. So here we add a value of beta. Beta is positive number, called the moment constant. Typically, moment constant is 0.955. Traditional backpropagation know this parameter. So many, when you have a model, some research will provide the similar method, but make some modify like this. He added the beta, beta. This equation called generalized delta rule, generalized delta rule. Now, in fact, he hope to improvement the operation. So here, learning with moment for operation equals all. He find the learning rate fixed. That he can get better and quickly to get the near sum of square error. Sum of square error. So this is a summation of the most important part of how to multiply the neural network. He said to estimate the convergence yet avoid dangerous instability, we apply two heuristics. Heuristic means the guide or method to guide the neural network operation. He said the first one, if change the sum of square error as the same error sign for several consequent actual, then the learning rate parameter should be increased. So what the meaning? Because the error rate, sum of square error rate has the same error for sign. The same sign, that means also on one side. So at this time, you can increase learning rate. That is quickly. That means like this figure. Because your learning rate usually on this side, on the same side. Same side that means that maybe you have draw a line here. That he is above this one. So at this time you can step quickly, to more quickly to get the result. This is the heuristic one. And heuristic is the sign of change the sum square error alternative severe consequence, ours should be decreased. That means if the error like this, so sometimes your learning rate setting, it became this norm, and then became this norm, that means your steps are too big. This like the great descent method, that became the oscillation, that changed highly. At that time, our learning rate need to be decreased. This is the policy about the learning rate setup. Affect the learning rate requires some change in backpropagation algorithm. If the sum of square error at current actual exceeds the previous value by more than a predefined ratio, the learning rate parameter is preserved, and new weight and threshold are calculated. If an error is less than previous one, the learning rate is increased. This is because the learning rate in fact control the speed of the get the answer, get the error. Learning rate with moment. So another topic, do you have ever, this is the Hopfield neural network. Hopfield is a different kind of neural network, but his neural network structure is simple. That is the brain, like the brain memory. However, work are association. For example, we can recognize familiar face in an unfamiliar environment with 100 and 200 milliseconds. We can also recall a completed sensory experience, include sound, sense, when we hear only a few parts of the music. That means that the association Hopfield network is like an association neural network. Association is that because when I am walking maybe on the street, you far away to look me, you just only find I am walking, but not find my face. But on your brain, you can organize. This one is professor, or this one is your supervisor, even very far away. So also, when we hear the sound on the group of the people, so you can understand that sound is the people you understand, you recognize. Like a sheep, a group of sheep, that the sheep mother can easy to find his children. That even thousands of the sheep in this area, the small sheep have a noise or sound, and his mother can find it. This is our brain capability of the association, associative. So Hopfield network architecture is a hope to, from a small knowledge to recognize the real one. Okay. This idea of the Hopfield. So hopefully is this is RNN, RNN, that is like the RNN idea. Multi-layer neural network trained with backpropagation algorithms are useful for pattern recognition. However, to enumerate a human memory associative characteristic, we need a different type of the network, a recurrent network. Recurrent network has feedback loop from the output to the input. The presence of the such loop has profound impact on the learning capacity of the network. In 1982, that proposed this kind of the neural network. The structure of this neural network is very simple. This is input node, and then this is the output node. But the input node connection is different. Here input this node means that have a connection, have a connection like the DAM neural network. But here is not connection. And his output is feedback. Feedback. For example, node 1 feedback to which node? To node 1 feedback to S2, right? No, to Si, to Sn, but not to S1. Okay. And node 2, output Y2, feedback connection to this one, but not to inside. So this roughly how you find is like this. You can connect to the network. So this network connection he has 2 there, and then is there, and he will not here he at that time he connection, but he feedback only feedback to here, and feedback to here, and this node he feedback to here, not feedback to inside. This is a special neural network, but this neural network can be implemented based on a weight of the matrix. Now when you give an example, here have 1, 2, 3, 4, 5, 6, 7, 8. Here have a node. In fact, here has a node. And then if you give me a node, I can understand this node from his some connection. So hopefully I can do the work is recover, to do the recover something. Recover something. I ever checked Hopfield network previous, but if we track this, we waste a lot of time. You just only understand have an idea of this type of the neural network of fear. You can trace this. Okay. And then we introduce about other neural network, that BAN. Whole field network also supervisor neural network because you need to input, you need to tell him this input need to belong to which class or which kind of output every pattern. And bi-direction associated memory. So other these two neural networks, their idea also is from our brain, not only single neural network operation. He hoped to find this neuron will affect by other neuron. So from this type of idea is then became unsupervised learning, unsupervised learning of neural network. Bi-direction neural network architecture is like this. Its structure also simple. It has only two layers. These two layers but this weight is bi-direction. This weight is bi-direction. So on forward direction, with reasoning. This type of structure only two layers, no hidden layer, input and output. And then he also from here to calculate the input and repeat to do this forward and backward, just only this type of operation. That is the BAN. The best idea behind the BAN is to store pattern pair so that when n-dimension vector S1 set as is present as input, the BAN recall n-dimension vector Y from set B. But when Y present as input, BAN recall the S. That means he can, from the output, he can reason in the input. From input, he can reason in the output. That became the bi-direction reasoning. Bi-direction reasoning. So their model also not completely. But even this simple network, but they can also do many things. Now, then this part we start here. Last week on Chuang class we have online testing. So we discussing because most students get can you find the correct answer? No? Not. Okay, let us
discussing about
our testing last week. So this one.
Yes, yes. Student entrance. Next one. Next one.
This one.
No. Next one.
So
The answer is this one.
student answer.
The right answer also in this one.
So the question of this one, that concern a chemist agree if point is 3 point here, only 1 point are assigned to the first class. Now, what is the new centralized for this one? So this one is try to find the, in fact you also did not to calculate, you just draw the graph, you can find which one is the best. So sometimes this kind of testing, we usually you can find -3, -1. Here have a point, and -1. S is -1 and 1, -2 and -1. So the node is here. So the weight is nearby here. So which one is the best? The best. Most people, we have 6 students, only one is error. So which one? -2, because in the middle is -2, -2, and 2 nodes are up, so are here, so it's more close. This one, 1. 3 is here, is impossible. 2 is here, no consider this one. 2 is on this side, is impossible. So answer is this one. Okay. And this question, that all the student is correct. That just open book. You need to understand the step of the genetic algorithm operation. All the student is correct. Our answer is this one. And this one have many students wrong. Only 2 is correct. The goal of the class a set of vector is to we do the class is to not choose the best vector from the set. Now class is to group. So divide them into group of vectors that are near each other. That is grouping or classing. But most students, all above is right. This one is not right. Determine the needs, the neighbor of each of the vectors. Now sometimes he not determine the neighbor is needs. He just made a group because some node are boundary. He may be in this time he belong this group. Next time he belong to other group due to the weight, because he based on the grade of center node, distance of the grade center node. Okay, so better solution is B. B. And this one, 2 is wrong. Our video test, we also have a question about this. This type of question, we need to understand that from which view, that it said as the following tree, the score is benefit. Benefit is from A move, which statement are correct. For the A move, we can find that this one. For A move, A will select the best benefit for him. So A1 will select 0.37 and in fact, A2 will select 0.6 if no cut. No cut. So A1 will select 0.3 is wrong. B will select 0.4 is wrong too. Because A2 will select 0.6 in this step. So B1 no opportunity to select this one, but he select this one. And then 0.6 can be cut out. Can be cut out. Yes, because that is 0.3, 0.4. We understand B will select not benefit for A, so 0.4 can be, 0.6 can be cut out. Okay, have problem? So this is correct. From A point, we set our cutoff. From B point, we set the beta cutoff. And this figure is, the top is B, so that is beta cutoff. That is our from A view is our cutoff. Okay. And question 4, the step of Madani Fajik. I think still have 2 students is wrong. Now be careful. Be careful. That is also on our book. On our book is from define value. Define value, and then we classification value, and then we do a evaluation, and then aggregation. finally it do the defagi. This is the step. And this question is more students are wrong. Now you hope to use up car knowledge. There are brands like Ford, BMW, Benz, Civic, Toyota. Each brand has different model of car, and each car has different function. What kind of knowledge representation is better to use? Because this kind of use rule is not good. Tree also not very good because tree have a branch and have some order. And this kind of knowledge, friend is better. Friend is like a ship. You go to 7 or go to family. That something is put on. That is friend. That you can BMW brand and use the friend knowledge that item. That is like we give you a case reasoning. That example. That is brand. Friend. And then the 7, check below all the apply chemist arguing. This is a multi-selection. So the answer that is the B and C. So chemists always converge to a class that minimize the mere square greater representation distance. And this is not correct. Can converge to different final class depend on the initial choice of the reference. D is right. D is right. This is not practice. Practice. Our correct answer is that question we check again. We find the last one. About fuzzy reasoning method, which one is correct? This is the fourth student is wrong. Who is correct? Who is correct? So a Madani method is suitable for control. That is not correct because Madani method need to many computation or falsification. Sucral is model is better for control. So this is wrong. Sucral method is more human-like. No. Madani method is human-like. So this is wrong too. Sucral method is practiced for dynamic nonlinear system. This is right. Because he just a spark function can respond quickly. Madani method is computation effective method. This is wrong. So correct is C. And above question, is correct is this two. Chemist in fact is widely used in the class scheme. For example, in machine learning, we do some pre-processing. Usually use Chinese method of Chinese. But he not always converge to the minimum because this part have 3 students select. He just choose just class team. Because the distance also have no mere square factor. So better solution is BC. Okay. And today have a student can report the previous our conference paper. Okay, who can report today? Right hand. Who? You? Okay. You upload the already upload? Okay. Okay. We use this week and next week to finish report. Okay. If you can finish, we take a 3 minute for break, and you please come here to, or you use my computer or your computer. Okay.
On our slides, I also put the step how to set up. You can reference. So this is my student entry. You also set up the step how to construct the paradox and TensorFlow environment. So, we don't in front of my is Chinese. So you cannot see Chinese. Okay, here. Here I open your file.
Yes. Yes, ma'am.
That is put on the homework.
Yes.
And
Record.
record this one. Which one? Which one?
This is the question. Please find my by the third one. Yes, that one. PPT. Yes,
PPT. This one.
Okay.
Okay, good morning everyone. We presented the paper with the title Fuzzy Cruise Control for Connected Vehicles based on vehicle networking. So this paper, the author of the paper is the other guys, the Bubu. You can spell it yourself. And okay, and this is the outline for the paper. The break into 5 sections: introduction, system structure, fuzzy cruise control, and simulation action, and then the last is conclusion. So this is for the introduction. As you know, the vehicle networking nowadays is become a popular topic. Yeah. And then some of many technologies became the foundation of the vehicle networking. This is the small part of the vehicle networking or smart car, something like that technology. So in this paper, the authors want to implement the fuzzy barrier or fuzzy inference system with the ACC or adaptive cruise control in the car. You know, maybe some of you know the car has some feature to adapt the speed, the cruise control, so the car can automatically adjust the speed and the movement with some kind of environments. So in this paper, they want to calculate the factor of the automatic driving from the cruise control, like the distance from the outer vehicle and the speed from the outer vehicle. And they use fuzzy inference system to do the calculation. So they want to calculate the speed and distance of the fleet. For example, if we drive our car in the highway and there is another car in front of us, so the car can be automatically adapt the cruise control with the other cars in front of it. So, and then this is the system structure. So the paper will build the simulation like this. This is the figure of the network structure in this paper. So they use total five cars in their simulation, and the vehicle number 1 to vehicle number 4 is the human driving vehicle. So it means that it's manually driven by humans. Also, they said that the driver is professional enough to tackle the professional driving like that. And the last one, the fifth vehicle or A1, VA1 is the automatic vehicle. So they want to know if the A1 can adapt the cruise control depending on the 4 other vehicle in front of the A1. So that's the structure of the model from this paper. Something like that. And this is the design of the method, the basic cruise control that this paper will develop. So as maybe you know the step of the fuzzy system. So the first one, they acquire the fuzzy input. For this case, the input is the velocity, spacing means distance, velocity means the speed or the acceleration of the vehicle, and two inputs. They have two inputs and one output. The final output is the acceleration. So the automatic vehicle can speed up or speed down, something like that. And then they process the fuzzy, the collected data, and make the membership function for the three items: velocity, spacing, and acceleration, and make a fuzzy rule, and then get the fuzzy output based on the fuzzy rule and defuzzification. This is the general methods, and this is the membership function for the first input. So you can see this is the membership function for distance or spacing, distance L1. As you can see, we have they have five inputs. Five membership. This is for distance from 40 meters to 90 meters, and then separate into 5 membership. So VS is very small, S is small, M is medium, B is big, and VB is very big. So they use two kinds of membership function. So S, M, and P is triangular, and PS and VB is quotient membership function. So as you can see, it's the different triangular, and it's something like sigmoid function. So this is for the distance or L1 input, and this is the membership function for velocity of the speed of the atom vehicle. So for the velocity, it ranges for 60 km per hour to 120 km per hour, and it's also divided into 5 membership, same like before, PS, S, M, P, and VP. It also have a similar membership function, triangular and quotient. Yes, and then this is for the output membership function for acceleration or accelerate A. For this membership function, they have 1, 2, 3, 4, 5, 6, 7 linguistic sets. For NP is negative big, NM is negative medium, NS is negative small, Z0 is 0, and PS is positive small, positive medium, and positive big. They also have 2 quotient in the top end, and triangular in the middle, something like this. So as you can see, the range is from negative 5 to 5. It means the acceleration is negative 5, it means slow down, and acceleration is positive, will be speed up. Acceleration will speed up. And this is the rules that they design. So they design these rules from skilled, experienced drivers. So from their experience, then they design this kind of rules. So for this is, it means I may have this example for very small distance with very small velocity, and then the acceleration will be negative big. It means slow down. Negative big is negative 5, so it will be slow down. For short distance and slow speed, it means like slow distance and slow speed, and then brake. But if long distance, very big distance, and then very big velocity, it means very speed. The speed is very big, and then positive speed, it means speed up. It may catch up, something like that. And this is the fuzzy inference system. So they use Mandani because the system would like to be human, like from the last recent example. So they have 2 inputs and 1 output. This is the system with 25 rules. So the rules is from here, you can see this is 25. And this is the surface area for the fuzzy system. And this is example of the simulation result. So from the paper reference 14, it's usually the safe distance or braking distance is at 44 meter, and the speed is 71 km per hour. So they set this kind of parameters from reference number 14. So they, it's like following other papers. So they set something like this. For example, this is the input distance is 100. The velocity is 100, and the speed, the speed is 100, and the distance is 70, and then yeah, it can follow the situation. This is the simulation result for all of the system that they run, and they want to achieve like this one. For example, if they want to in the speed of 100 km per hour is how many time, how many long that the automatic vehicle can adapt with the other vehicle. So for the example, for this graphic, I mean, as you can see, the red line is the output from the automatic vehicle, and the black line is from the manual or human driving vehicles. As you can see, the human driving vehicle speed may be vary in the first time, maybe 100 and then go up and go down, but in the maybe in the second 25, in the 25 second, and then the speed will be stable. And as you can see, the automatic driving vehicle at the first, he need to adjust many times, like for in this graphic from 80 km per hour, maybe it speed up to 120 and then we go down, and as you can see, it becomes stable at around 30 seconds. So the automatic driving vehicle can adapt to the speed at around 30 seconds, I think. 30 or 25 seconds. This is the same graphic, but they remove the black line, so we can see clearly that the automatic driving vehicle can adapt to the situation between 30 to 25 seconds. So the conclusion is, with the fuzzy inference system, we can make automatic driving vehicle can adapt to the environment and use the fuzzy inference system to cruise control, adaptive cruise control for sake of safety and fuel consumption economically, something like that. So it also shows that the system can adapt for short time, something like 30 seconds. So it makes a good economic value for automatic driving vehicle. Okay, that's it.
So what is the safe distance? He has defined the safe distance.
The safe distance, the paper just refer to this paragraph. So the safe distance between vehicle is
vehicle.
Vehicle to vehicle is in this one. For the speed of 71, the safe distance is 40 meters, something like that.
So need to transform.
If the speed is not 71, maybe the distance is also changed.
Okay, thank you. And then who can return next one? Just use this computer, okay? You not. Do you have modify or just up, download? You need use this.
Hello. Yes. So, hello everyone. So this is my presentation topic, which is credit risk prediction in peer-to-peer lending with lending with ensemble learning framework. So the author is Rung-Ching, and so on. So everyone is know about the peer-to-peer lending, but I can explain the in the P2P lending. So if you want some borrow money from the bank, so the in the P2P lending there is a one platform where you can share your information, and then they calculate your information and checking everything, and then they will give you the lend the money to you, and after that they will check your credit risk also, कि you can pay or not. So there is my outline where the key factors and introduction, purpose, related work, and proposed method, which is proposed in this conference paper, and experiment and future scope and conclusion. So in the key factors there, peer-to-peer lending, ensembling learning, autoencoder, and logistic regression, which is used in this paper. So there is introduction part where they are defined. The online lending platform has a large number of transactions every day, and the borrower credit needs to be evaluated before lending. So whether the borrower can repay the loan on time or not will have a great impact on the effective operations of the online platform. So with the development of information technology and the rapid growth of the variant data, machine learning has been widely applied in the industrial world, for example, product recommendation, ad calculation, and real-time transaction. So the main purpose of this paper aims to employ the machine learning and neural network to solve the credit risk prediction problem of online lending. And in this paper, they using an ensembling learning method was designed, which was combined with tree model and autoencoder to construct the model framework. It is based on the historical data that the chance of whether a borrower will repay or not. And it is a reasonable to assume that the borrower repay time is good, otherwise it is risky. And in this paper, the good borrower are regarded as a negative samples and risky borrower as a positive sample defined in this paper. And the prediction process of machine learning techniques may not only improve the efficiency of the online lending platform, but also reduce the lending risk. Here some related work which is already techniques are used previous research. So the one topic is the support vector machine for default prediction of SME based on a technology risk. The author Kim and Son is proposed the method in 2010, and other Lin and Susan in 2017 they proposed a method for credit scoring informant using optimized logistic regression, and other is credit card forecasting by logistic regression and decision tree, and food hazard risk assessment model based on random forest. So in this slide there is a proposed method. So in this paper they used a gradient boosting decision tree, which can be thought of as an assemble of decision tree. As you can see in the image, where they input the value and base classifier, then training, and they calculate the weight. After that, the assemble method used. So the GBT generates a base classifier in each iteration, and each classifier is trained to the fit of the previous classifier without fitting. Next, they use this equation, which is weight, how to calculate the weight. Model can be ultimately formulated as equation, where Txm indicate a base classifier, the eigenvector is denoted by x, and theta m indicate the parameter in a single tree model. And they use the unbalanced data processing in this paper. So common method for balancing positive or negative sample data are oversampling and undersampling. So here oversampling is to balance the positive and negative sample by the expanding the number of positive samples. And the next is undersampling is it to balance the positive and negative sample by reducing the number of negative samples. And here in the graph, they use the smart algorithm generates a new samples where x is equal to x plus alpha and x1. Here I can explain the step here, next slide. So the smart algorithm is used to solve the problem by creating synthetic minority class, example shown in which is last slide in figure. So the step is step 1 is smart algorithm and positive sample are randomly select the value. In the step 2, each samples x and the m nearest positive samples to x are determined. And next, the sample is chosen from the m positive samples denoted by x1. And step 4, a point between x1 and x and x1 is randomly chosen. And the new sample is shown in above formula, which is in the last slide. So x and x1 indicate 2 points, is a coefficient with a range between 0 to 1, and the blue dots and the red triangles here. Here you can see in the red triangle. So triangle indicate 2 types of samples. Next, the data set process. In this slide, they separate the data in 3 parts. 2 parts for training, 40% part for training, and 20% for testing. Some researchers use the training for 70% and 30% for testing, but here they use 40% and 40% for training. Training part they divide in 2 parts and other in testing parts. So there is the assembling learning framework, where you can see that there the training, then GBT algorithm use the one hot encoding and autoencoder and logistic regression, and then output. So this is the proposed framework which is they proposed in this paper. So in the graph image, you can see the GBT model with the input of the trained data 1, that the leaf nodes 1 which the trained 2 data might fall or predicted, leading to new feature being found. And second is one hot encoding, taking the output from the GBT model as the input, and the feature vector is encoded into the point of Euclidean space, and that is each one valued element will be converted to a point expressed by some unit vector. And third is the autoencoder. Since the dimensions of one hot encoding output have increased dramatically, the autoencodes is used to reduce the dimension. And in logistic regression, taking the output from the autoencoder as the input of the LR model, which is a long linear model for binary classification problem. And there the computational experiment, they use the million data from the Kaggle website, and the number of attributes and number of positive samples, or their number of negative samples they mentioned. And in this paper, they used this algorithm. They use the programming language, which is Python language. and the language they are GBT, AER, and decision tree. They propose the GBDT, AER is the proposed method in this paper, and they also define comparison of the GBT, AELR, and GBTLR. And in the result, they found the 4 models are trained, after which the classification results are obtained by the model in terms of that test data set. So figure shows the ROC curve is computational result may be models, the proposed models of or GBDT, AELR has the highest AOC, and the decision tree model has the worst AOC, 0.732 as shown in table. You can see that GBT, AER, AOC, and logistic, and decision, and GBT, LR. So the highest AOC is GBT. So this is the proposed model, which is I think the best. So here they compare the GBT, AELR, and GBDT, LR. Here we can the data say they use the number of subtree also 20, 30, 40, 50, and in this image you can see the GBT LR model, even though it's give rise a better AOC or GBT AER model. In general, given GBT use more subtrees, and GBT AELR model tend to have better performance. So provided GBT use little subtree, the GBT LR model is better than the GBT AELR model. So in this this is the conclusion part, where in this paper the credit risk prediction problem of the P2P lending has been studied with ensembling lending framework, and multi-stages ensembling lending model is proposed for the borrower credit classification, and the experiment results show the proposed model is effective for the credit risk prediction, and in future we can use deep learning, and deep learning parts CNN and RCNN also, so they can enhance the prediction accuracy with the respect to the sequencing loan application. Thank you.
Okay, you have a formula, S hat equal to S1, S8, S1.
H1, H1?
Previous. Okay, the formula of S equal.
This one. Yeah.
And what the meaning of S hat, S and S1? What the difference? S1, for example, S1, S hat, and S1.
Actually, the X1 is coefficient. The X1 when you input the value, maybe the value is X.
Yes.
We define the value. Suppose X1, X2 like this. So I use the X and X1 for this.
So S is different with S1.
Yes, X is different from the X1.
S is the, what is S? What the difference S and S1? For example, in this figure,
yes,
we can find what is.
So in this figure you can see the blue dots, the other inputs, and the red dot is other inputs. So we can define as a X is a blue dots, and X1 is a red.
That is like a Canon
algorithm.
Yeah, Chen near neighborhood.
Yes. So so they select the near value
to make decision which one is this node is risk
near
or not risk.
Yes.
But what is small t algorithm? Small t. SMOT algorithm. What is this algorithm?
They use in the some paper the small
Other
yes.
paper.
Yes, so they use. I don't know about very much too, but I little bit.
But here, because when we do the mathematics, we better to understand
yes.
the meaning
Yes,
of
yes.
even the parameter.
Yes,
what
yes.
the meaning of parameter. Okay. Okay, thank you for presentation. So the remainder student representation that may